Hi and welcome to another Boom Web Search Technology explanatory video. Last time we explained 4 of the most basic types of the 7 simple types of logic gates. Today is going to be kind of an extension to that video, and the additional 3 gates being covered are going to be the ENOR gate, the EOR gate, or the NOR gate. So think of this as kind of an extension to our last video introducing this subject. We're also going to be covering basic examples, although if you want to know more about what logic gates are in general, then I suggest watching the previous video, as that's going to give you some more insight towards what that is. Now we'll roll out our short video intro segment and then get right to the content. So see you after the short video intro segment. Okay, so let's get right into the video with our first topic, which is going to be to explain what the EOR gate is. The EOR parentheses exclusive OR gate is a type of gate which outputs a 0 if both of the inputs are 0. A 1 is outputted in the case of A or B being 1 while the other is 0. And if A and B are both 1, then the output is 0. So look at the table for a graphics version of this concept. So if A and B are 0, we get 0. If A is 0 and B is 1, we get 1. If A is 1, B is 0, we get 1. And if both B and A are 1, we get a 0. So a real world example where this type of gate could be used would be with a door and a light scenario. So if you want the light to shine and the voltage being sent as in terms of 1, then you want the gate to have it where either if A or B, so let's say in a car we have 2 doors. So if either of the doors is opened, then you want the light to shine. So if the first door is closed but the second is open, we're still going to have the light. If the other one is opened and the other one is closed, we're still going to have the light in that. So what we're wanting to ensure is that the light is played, or essentially given voltage to, if one or the other is opened. Although this would mean that if you open both of them, then the light's not going to show, and if both of them are closed, then also the light is not going to show. Okay, so let's go on to the next type of gate here, which is going to be the NOR gate. The NOR gate is a type of gate which gives you a 1 if both of the inputs are 0, a 0 if A or B is 1, and a 0 if both of the inputs are 1. Look at the table for a graphics version of this concept. So if we put in both zeros, we get 1. If we put a 0 and a 1, or a 1 and a 0, we both get a 0. And if we put in 1 for B and A, we get 0. So a real world example for this type of logic gate is for printers. So printers have a toner cartridge, and the way the printer unit knows if the toner cartridge is running low or if there's pretty much minimal toner left within the cartridge is it shines a beam of light through one side of the cartridge, and on the other side of the cartridge there's just going to be a receiver unit, and that determines if light was received or not. So if it's going to have like no light received at all, then we're going to get the warning message. although if it can see some light, like if in the case that there's no light coming through the cartridge, then we get 1. Okay, so if there's going to be some light like going through and then some of the light is not going through, we're just going to consider that it's just not time to replace the cartridge yet, and the light is just not going to show. And the next type of gate which you're going to be explaining here, and this is going to be the final type of gate we're explaining here for the purposes of this video, is the ENOR gate. And it's a type of gate which gives you a 1 if both of the inputs are 0, and a 0 if of the inputs is a 1 and the other is a 0, or vice versa, and which inputs a 1 if both B and A gates are 1. So look at the graphics table below for a visual of this concept. We write in both zeros, we get a 1. We write in a 0 or 1, a 0 and a 1, or a 1 and a 0, and then we go both get 0, and if we write in 2 1s, we get a 1. So basically, this idea could be applied in the real world in the case of there being a door and a light. So this is going to be more in reference to general room lighting. So if we notice that, okay, we only want light to show if, well, actually a better idea would be a fan switch. Light could work out, but so for purposes of this video, I'm just going to make up a scenario with a fan. So we want circulation to be present. So if both the doors are closed, we're going to have 1 because we still want circulation. If one of them are still open, it's going to let some air into the room, so we don't really need to turn on the fan. If both of them are open, then it's probably something that the room is in use, so for extra cooling, we're going to run the fan. Okay, so now we're going back to the light concept. If both of your doors are, well, let's say both of them are open, actually, we're going to get a 1. And if one of them is open, then we're not going to get any voltage sent to the light because the light's coming in. And if both of them are open, we're still going to run the light, although that kind of seems weird, which is why the fan example is probably more applicable for most cases for this concept. So just a quick reminder here in case I did mess up with this, and I'm going back to it in the video editing stage. If we're putting out a 1, this means whatever in the end function is going to be initiated, and same thing here. If it's going to be a 0, then it basically means off. In the case of a door, actually, I kind of think that there is going to usually be a gate that switches it, so it could have been thought of either way, although in the most simplest form, we're going to say that a 1 is there if the current flows all the way throughout it, meaning that it is in fact closed, and therefore goes to the output. Although, as I would see it, most of the time there's multiple modules that work together and it's not all on one unit, so I'm going to assume that it's switched in the fact that if it's in fact open, then we're getting a notification basically that in the end it is open. So that's kind of tricky, although a lot of these gates are put in very complexly in processors, and there's many gates, as I've explained in the previous version of this concept, which I totally recommend checking out, and it gives a lot more of the information towards what this is. So a lot of these gates work in conjunction usually. Usually you won't find things with only one type of gate. It's pretty rare nowadays with so much advanced and modern technology as we continue to evolve it. Although these are just some of the basic, most simple types of gates, and I want to explain the basic inputs and outputs and what they can be used for in different applications. So in the future, maybe we'll go a little bit more in depth. Maybe we'll cover some other gates. If you have some of these in mind, please let us know in the comments section, and we're definitely going to consider adding some of those gates in a future information video. Although now it's time for the outro. Oh, right about time to explain one more thing. Last week I pushed this video to this week, which is now, because there was a form update. I'm still working on some changes to our form. Hopefully I'm going to make another update video and show you some of the new changes which we've applied. We're still in the development process with the new features and changes, although hopefully next time we'll get to roll out another version update of our form. Although if that doesn't happen, then we'll just push it back later sometime and have another regular content or information technology based upload. So now for the video outro. Thanks for watching. Thank you so much for watching this video which is generally towards logic gates. Please make sure to subscribe to this channel, parentheses boom upsearch if you have not done so already, and have your bell notifications turned on to prevent missing any of your future content uploads. Note that the bell icon only appears to the right of the subscribe button after you've already been subscribed to the channel beforehand. And if you have any future video suggestions pertaining to the subjects of computer software, computer hardware, technology topics explained, how technology works, or basically anything tech related, please let me know in the comments below. As always, thanks for watching, and I'll catch you in the next content upload. Bye!